Hello and welcome to our lesson on factoring trinomials. Just as a review, we started factoring a few topics ago, and it is the process of taking or rewriting one polynomial as a product of two or more. So we said sort of like the reverse of our multiplication process. Okay, and so far the factoring we've looked at it's basically been GCFs, right? We can look at any number of terms and take out a GCF if they all have something in common. And then we can use the concept of GCFs to factor a polynomial with 4 terms by grouping, where instead of looking for a GCF for all 4 terms, we cut into 2 groups and GCF from there. Okay, now so that we can see the difference in the types of things we're going to be factoring today, we're going to start with the multiplication process so you can see where the trinomials that we're going to be factoring are coming from. Okay, so let's multiply this out. If I said to multiply 2x plus 1 times 3x minus 4, we would start by distributing the 2x. So 2x times 3x would get us 6x squared. 2x times negative 4 would give us a negative 8x. And then we'll distribute the 1. 1 times 3x gets us a positive 3x. And then 1 times negative 4 gets us a negative 4. And now we see some like terms in the middle that we can combine. So we have this 6x squared. When we combine the negative 8x and positive 3x, remember we're combining those coefficients. Negative 8 and positive 3 makes a negative 5 in front of our x. And then we have this minus 4. Okay, so when we're going this direction, again, that is our multiplication process. We are multiplying these polynomials. And what we're going to be trying to do today is work in reverse. We are going to be looking at these types of things, these types of polynomials. These are trinomials, and specifically quadratic trinomials. Remember, that means we have a degree of 2. And how do we factor the quadratic trinomial, or how do we factor trinomials in general? How do we work from this one polynomial and figure out what we multiplied to make that happen? Again, that is our factoring process. So some good news. If we have a trinomial, it is always the result of multiplying 2 binomials. Okay, our trinomial comes from the product of 2 binomials, the ones that we're going to be factoring. Okay, so we know when we're factoring, if I were to give you this as our problem, that I know factoring I have to figure out, okay, I multiplied 2 binomials to make that happen, right? The question is, how do we figure out what's happening there? Well, I know that my first term here was the product of my first terms here, right? That's just kind of carried down. And I know that my last term here, right, that was the product of my last terms here, and that just carried down. So we're going to use that to kind of start, and then I'm going to show you how we're going to finish this process. So I'm going to deviate from our note sheet just for a minute. Okay, let's say we were going to be trying to factor something like x squared plus 3x plus 2. So since this is a trinomial, I know it's going to be factoring into 2 binomials. Okay, and then whatever I have first here, that was the result of what I multiplied first here and here, right? My first 2 terms in my binomials gave me my first term in my one polynomial. So what could I multiply to make an x squared? Well, there's only one thing I could multiply to make an x squared, and that would have to be a 1x times a 1x. So that's going to get me that x squared. Okay, so we've got that piece. Now remember the end number here, that was a result of the numbers multiplying the numbers that were in the ends of each of the binomials. So if I need to get a 2 here, then what 2 numbers could I multiply to make 2? Well, again, not a lot of options. What would I multiply to make a positive 2? A positive 2 and a positive 1. So if I put a plus 2 here and a plus 1 here, let's just see if this works out. It's going to, but just so you can see it. If I was to multiply this out, there's my x squared I said I was going to get in the beginning. There's 1x, and there's 2 more x's that combine to make the 3 x's that I have in the middle, and then the 2 times the 1 does make the 2 in the end. That wasn't so bad, right? The same thing for something like this next one, right? This is going to be the product of 2 binomials. What could I multiply to make x squared? Has to be an x and an x. And then what could I multiply to make 7? Has to be a 7 and a 1. And those are the only options, so we're going to stick them in there and make sure the rest of this works out, right? There's my x squared that I had in the beginning. There's 1x there, and 7 more x's, which would combine to make the 8x in the middle, and then the 7 times 1 makes the 7 at the end. So not so bad. Not so bad if our numbers are smaller numbers that don't have lots of factors. The issue is, and this is really just kind of a guess and check method, the issue is when those numbers get a little bit bigger, for example here. Okay, again, this is a trinomial, so I know it's going to be the result of multiplying my two binomials. This time, however, I have a 2x squared in the beginning. So what two terms could I multiply to make a 2x squared? Well, instead of an x and an x, I'd have to have a 2x and an x, right? Only options to get a 2x squared. Now here's where we start running into some issues. At the end here I have a 6, which means these two numbers at the ends of my binomials have to multiply to make 6. Well, I've got options, right? It could be that it's a +1 and a +6 to make that happen, or does the +6 go with the 2x and the +1 go with the x? Or it could be a 2 and a 3, like a +2 and a +3 here, or does the 3 go with the 2x and does the 2 go with the 1x, right? Then all of those options would have to be checked to see which pair in the right spot is going to add up to get us the 13 x's in the middle. And that guessing and checking process, to me, is just a little too inefficient. I don't want to have to guess and check. And some of you might have already learned this with guess and check, and you might be totally comfortable doing that. And it's a perfectly acceptable way of factoring a trinomial. But for me, it takes a little too long. So I'm going to show you a process that it's called bottoms up. You'll see why in just a little bit. That works every time for these trinomials, and of all the methods that are taught, this one is the fastest. Okay, and that's really the goal, because in some later chapters you're going to see within one problem we might have to factor 3 or 4 trinomials, and we don't want to have to do something that takes a long time 3 or 4 times just in one problem. All right, so here's how bottoms up is going to work. We're going to start by multiplying our first coefficient and our last number, which is our constant, so the 2 and the 6, first and last numbers, and that product, if we multiply those, we get 12. Okay, and then we want some factors of 12. I'm just going to list out pairs of factors. So 1 times 12, for example, or 2 times 6, or 3 times 4, right? What I want in my pair of factors, right, these are all pairs of factors, but I want to choose the pair that adds to the number that I have in the middle. So 3 and 4 adds to 7, 2 and 6 adds to 8, but 1 and 12 adds to the 13 in the middle. So I know that I'm going to be using my 1 and 12 as my factors, okay? So 1 and 12, once I find these factors are going to be divided by my first number. So I'm going to take this factor of 1 and divide it by 2. I'm going to take this factor of 12 and divide it by 2, and that leaves me 2 fractions. Now, if one of them is reducible, I want to reduce. The 1/2 doesn't reduce, so that's going to stay, but 12 over 2 reduces to 6 over 1. Okay? So now these 2 fractions, I'm going to read from the bottom up to give me my 2 factors. Remember, I'm looking for these 2 factors, these 2 binomials. So this first fraction, I'm reading from the bottom up as a 2x plus 1. So a 2x plus 1, where the bottom of the fraction is the coefficient of x and the top of the fraction is the constant. And then the second one, again, read it from the bottom up. That's going to be 1x and then plus 6. 1x plus 6, and there it is. Factored, right? About as quickly as you could factor. And again, look at check this. There's my 2x squared in the beginning. There's 12 x's there and another x there to make the 13 in the middle, and then 1 times 6 is 6. It works. Okay, let me just show you another one, and then we'll go back to the note sheet. So let's say we had something like, I don't know, 4x squared. Let's put a plus 5 here, and then let's put 21x in the middle. Okay, so we're going to multiply. We have 4 times 5, which makes 20. And factors of 20 could be 1 and 20, or 2 and 10, or 4 and 5. Now what I want is the pair that's going to make the 21 in the middle. That when I add the pair, I can add to make the number that's in the middle. And that's going to happen with 1 and 20. So I'm looking for a pair of factors that adds to the middle number. Now once I have them, I'm going to divide by my first number. So I'm going to divide the 1 by 4 and divide the 20 by 4. And this doesn't reduce, but this becomes 5 or 5 over 1, and those two fractions I'm going to read from the bottom up to get my factors. So 4x plus 1 is going to be a factor, and 1x plus 5 is going to be the other factor. Okay? That's it. I don't know if your mind is blown right now, if you've ever seen this process before or not. And again, if you have another process that you've already learned, some of you have learned some like X thing, where I don't know. I don't know exactly how this works. Where there's like 4 here, and then you put the 20 here, and it's the same kind of thing, it's a different way to organize, but if you have learned another way to factor and you are comfortable with it, by all means use your method for factoring. This is just over the years the one that I've found to be the most efficient, and I've seen students have the most success with. Okay, so this is called bottoms up because once we get these fractions, we read from the bottom up. And let's write down some steps and try out some more. It does get a little trickier when we throw some negatives in there, but I'll show you how to handle those too. So we're going to start by multiplying our first and last numbers. And this has to be in order. I think we talked about that with factoring in general. Make sure your terms are in order first. But once they're in order, multiply the first and last numbers. Your first coefficient, last number is constant. And then you're going to find factors of that product that add to the middle number. And some of you might be able to see them right away. Some of you might need to make a list and then look at the entire list to find the pair. It's sort of however your brain works, okay? Now once you've found the factors that add to the middle number, you're going to divide them by the first number. And then you're going to reduce the fractions that are created if they're reducible. And then you read each fraction from the bottom up. Okay, the bottom represents the first coefficient while the top represents the constant. So again, if you were left with a fraction like, let's say 1/2, then you're going to read this as a 2x plus 1. So 1/2 becomes a 2x plus 1. Or let's say you had like a -5/3, then this would become a 3x minus the 5. So we want the sign to go in the middle of the binomial. Okay, so a 3x minus 5 would be your factor. All right, and then if you had a whole number, sometimes you end up reducing. Sorry, I should have changed colors. Put a comma here. Or if you had something like 10 over 2 that reduced to 5, you still want to look at the 5 as 5 over 1. Okay? So even though it just reduces to 5, look at it as 5 over 1, and that would become a 1x plus 5. Okay? That fit there? Just barely? Now it's all ugly. Let me scooch these guys. So this little, it's called a lasso tool that allows me to move stuff. It's slightly helpful. Let me do this one again because it's just crammed. Again, if you ended up with a whole number, so let's say you had like a 10 over 2, technically that reduces to 5, but you really want to look at the 5 as 5 over 1 so that you know that it's a coefficient of 1 in front of your x and then that positive 5. So 1x plus 5 would be your factor. Okay? Alright, so now, the nice thing too about when you're factoring is you can always check your work. Answers can always be checked by multiplying them back out, and that's something you can do in your head. You don't necessarily have to do on paper. Okay, so let's try this out. I think we might have had this one. Did we have this one here? Of course, we did. I duplicated. That's okay. So we're going to start by multiplying our first and last number. So 1 times 7 is 7. And then we want to find factors of 7 that make 8, and they happen to be the only factors of 7, which are 1 and 7. So once we have those factors, technically, we're dividing by our first number, but dividing by 1 is not going to change anything. So if we have a leading coefficient, that first coefficient is called the leading coefficient. If that first coefficient, that leading coefficient is 1, then once we have these numbers, we pretty much know what our factors are. 1x plus 1, 1x plus 7 is going to be how this factors out. So 1x plus 1 and 1x plus 7. This was one of those easier types we looked at where we didn't necessarily need a complicated process, but just so you see, bottoms up will work here as well. Okay? Now if we start throwing in negatives, it's going to make this a little more challenging, but let's see. I think we can do this. Let's multiply our first and last number. So this is 5 times a negative 4, which makes a negative 20. And now we want to find factors of negative 20 that add to negative 8. So I can tell right away that a negative 10 and a positive 2 multiply to negative 20 and add to negative 8. But that might be a little too much for you to do just off the top of the head. So if you're not a multitasker, or maybe it's just a little bit much for you, then start this by listing out all of your factors of 20. So all your pairs of factors, like 1 and 20, or 2 and 10, or 4 and 5. Now what we need is for the factors that add, we need the factors to add to the middle number. But notice here, this is a negative 20. If that number is negative, then the pair of numbers that we multiply here to make the negative 20, one of the numbers has to be negative, right? In order to make a negative 20, we're listing out pairs of factors. It could be that, that it's a negative, what the heck? I thought I put pen. A negative 1 positive 20, or it could be a negative 20 positive 1. But one of those numbers is going to have to be negative to make a negative 20. Same here. Is it a negative 10 and a positive, or negative 2 positive 10, or is it the reverse? Is it a negative 2 or 10 and a positive 2? One of the numbers has to be negative for the product to be negative. So if the number is negative and one of our factors has to be negative, then when we combine them, we're not really adding. When we combine them, for example, again, if the 1 was negative, when I add these numbers together, I'm really subtracting. So I'm looking for not a sum of the middle number when it's a negative. I'm looking for a difference to make the middle number when it's negative. So I'm looking for the pair that has a difference of 8. Okay, so a difference of 8. Goodness. So if the difference between 1 and 20 is 19, I know that's not going to be my pair. The difference between 4 and 5 is only 1. I know that's not going to be my pair. The difference between 2 and 10 is 8. That's going to be my pair. Okay, so let me just get rid of all this. I want to use 2 and 10. Because those ones have the difference of 8. I just need to figure out which one needs to be negative. So what I need is two numbers that multiply to negative 20 that also add to negative 8. So if they have to make a negative 8, then the 10 is going to have to be negative. So a positive 2 and a negative 10, those make negative 8. If I had a negative 2 and a positive 10, that would add to a positive 8, which is not what I need. I need a negative 8 in the middle. All right, that is the hardest part of this, is just finding your factors. And maybe for some of you, that was a piece of cake. But let me just go back here. Put this step up here. So when you're when you multiply the first and the last number, if the result is positive, then you want numbers that add to the middle. But if your number, if the product is negative, the difference, you need the factors, the difference of the factors to make the middle number. The difference of the factors makes the middle number. Okay, and I'm going to show you more, so if I've just talked too much and confused the hell out of you, I'm sorry. Okay, let's try this some more. So let me start this again. Okay, 5 times negative 4, we multiply, we get a negative 20. I'm looking for factors that multiply to negative 20 that also add to a negative 8. So because it's a negative number, I'm actually looking for factors that make a difference of 8 because I need one of the numbers to be negative. All right, so factors of 20 could be 1 and 20, or 2 and 10, or 4 and 5. But because this is negative, I'm looking for a difference of the middle number, and that's why I'm choosing to use the 2 and the 8. Okay, so I'm going to use the 2 and the 10. So I'm going to use 2 and 10, and if I make the 10 negative, then 2 times negative 10 adds to negative, or multiplies to negative 20. 2 plus negative 10 adds to negative 8. So they multiply to this number and they add to this number, which is exactly what we need the numbers to do. So once I found my factors, I'm going to divide by my first number. So divide by 5, divide by 5, and then reduce if I can. 2/5 doesn't reduce, but negative 10 over 5 does, to negative 2 over 1. So I'm going to read this as a 5x plus 2. 5x plus 2. And then here, 1x minus 2. And that's it. I'm all factored. And again, we can check this. You could do this in your head. But here's 5x squared minus 10x plus 2x to make minus 8x in the middle, and then minus 4. So it works. Okay? All right, let's try this out again. I think I did a little too much talking, and I'm sorry if I confused you with all my talking. But let's try again. We're going to multiply our first and last number, so 2 times 4 makes 8. I need factors of 8 that are going to add to 9. And this is a positive 8, so I really need them to add to 9. So 1 and 8, or 2 and 4 are the options for factors. Which pair is going to give us 9? It's got to be the 1 and the 8. So I'm going to erase these. So 1 and 8. Now, positive 1 and positive 8 do multiply to positive 8, but positive 1 and positive 8 don't add to negative 9. So in this case, I'm going to have to make both of them negative. So the negative 8, negative 1 still multiplies to positive 8, but now they also add to the negative 9 that's in the middle. So we're going to need negative, negative here. Now we're going to divide by our first number. Divide 2, divide 2. 1/2 doesn't reduce, but this does. Becomes a negative 4, or negative 4 over 1. And so one of my factors is 2x minus 1. And one of my factors is 1x minus 4. And that's it. All factored. Okay? So since I didn't ask you to try that one, if you want to give this one a shot, feel free to pause the video. Otherwise, we're going to multiply our first number, which is a 1, with our last number, which is a negative 12. And we're going to find factors that make 4. Now a difference of 4 this time, because our 12 is negative. So 1 and 12 aren't going to get me a difference of 12. 2 and 6, or 3 and 4, these are my options. Which one give me the difference of 4 that I need in the middle? Well, that has to be the 2 and the 6. 2 and the 6 is the only way I can get a 4. So I'm going to use 2 and 6. And again, 1 has to be negative to multiply to make a negative 12. And in this case, I'm going to make the 2 negative. That way when I add these, the negative 2 plus the 6, I get a positive 4, which is what I need in the middle. Okay? Now, technically, we're supposed to divide by our first number. But that's a 1. That's not going to change those. So 1x minus 2 is going to be a factor. And 1x plus 6 is going to be the other factor. Okay? Hopefully this is going all right. Something a little different happening in number 4. Maybe you can see it. But these have to be put in order first. So put in order first. If it's not in order, it's not going to work. Put it in order first if it's not already in order. So if I rearrange this, the 2x squared is fine, but the 5x should be in the middle and the plus 2 should be at the end. So now we can multiply. Let's change color here. So 2 times 2 is going to make 4, and then factors of 4 are either going to be 1 and 4 or 2 and 2, but I need them, this is a positive 4, so I need them to add to 5, and the pair that adds to 5 is the 1 and the 4. So now both of those get divided by 2. So divide 2, divide 2. 1/2 doesn't reduce, but this does. It becomes a 2 over 1. So 2x plus 1 is a factor. And 1x plus 2 is a factor. And we're done. Okay? Something a little different happening in number 5 as well. Can you see anything different in number 5? Well, hopefully you're noticing that this is cubic instead of quadratic, that each of the terms has an x in common, and actually a little more. If each of the terms has something in common, a GCF, then that's going to have to be factored out first. Remember in topic 1 we talked about GCFs? That's really the first step in any factoring process. So even if we're factoring a trinomial, if there's a GCF in there up front, that should come out, and then we continue. Okay, we just haven't had a GCF occur in any of the other problems. So here, we're going to take out the GCF first, and then we're going to continue to factor. Okay, GCF first. So the 2x is going to come out, and then when that comes out, we're left with, or divides out, factors out, we're left with 4x squared plus 5x plus 1. So in the GCF section, we said, oh, I'll take out the GCF when we're done. But here we can see we've got a quadratic trinomial left, so we're going to continue to factor that quadratic trinomial. So now we're going to work on the parentheses piece here. The 4 times the 1, which is 4. Factors of 4 that make 5 are going to be 1 and 4. That's what we had just a second ago. And we're going to divide them by our first number. So divide by 4 and divide by 4. This reduces to 1, or 1 over 1. So we've got 4x plus 1 as a factor, and then 1x plus 1 as a factor. And that's just the piece from the parentheses. We can't lose our GCF. Is still a factor of our final answer. So our final factored answer has all 3 of those factors, which makes sense if we have this third degree piece here that we have 3 different factors. Okay, moving right along. Oh, one for you to try if you want to give this a shot. Maybe you remember the rule. If not, this is a GCF problem again. Remember our first term, we don't want to be negative as we continue. So we're going to factor out the negative. Factor out the negative. Even though the 3 terms have nothing else in common, with that negative, we don't want to be in the first spot. So we're going to factor out a negative 1. So we've got a positive x squared, then a negative x, and then a minus 20. And now we'll continue inside of our parentheses. So 1 times a negative 20 is a negative 20. And we're going to be looking for a pair that has a difference of 1 in the middle. So 1 and 20 doesn't have a difference of 1. Difference, again, because this is negative. Okay. So, let's see. 1 and 20 doesn't have a difference of 1. 2 and 10 doesn't have a difference of 1. But 4 and 5 have a difference of 1. So I'm going to use 4 and 5. Which one do I need to make negative? Well, if there's a negative in the middle, I'm going to make the bigger number negative there. If I add 4 and a negative 5, I do get the negative 1 that's in the middle. Alright, so these are going to be divided by my first number, which is a 1. And so they're not going to change. So I'm going to have a 1x plus 4, a 1x plus 4, and a 1x minus 5. And let's not forget about our GCF, our negative that we factored out. That's got to be part of our final answer. Okay? Not so bad, hopefully. Hopefully this isn't so bad for you. Okay. All right, number 6 looks a little strange again, right? We've got some extra stuff going on in number 6, but if it is a trinomial and it's going to factor, it's going to work the same way as all of the other problems. So what makes this one look a little different is this extra y and this extra y squared. So let's just ignore it for a second, okay? Let's ignore it for a second. If we multiplied our first number and our last number, the 3 times the 2 would make 6. And factors of 6 would either be 1 and 6 or 2 and 3. But I need the pair that's going to add, because this is positive, add to the 7 that's in the middle. So which pair gets me 7? Well, it's got to be the 1 and the 6. Now both of those are going to be divided by 3. So divide by 3 and divide by 3, and this reduces to 2 over 1. So if those y's weren't there, we would be done, right? We'd say 3x plus 1 is a factor. And I'm purposely going to leave a space there. And then we would say 1x plus 2 is a factor. Okay, now think about why we put those x's in the beginning in the first place, right? When I multiply this back out, I need an x here and I need an x here because that x and that x gives me the x squared that's here. And that also gets me an x to the first and an x to the first. It gets me those 7x to the first that are in the middle, right? So if I need x squared in the beginning and x to the first in the middle, I achieve that by putting an x in the beginning of each of my binomials. Well, now I also need to have a y squared at the end. So if I put a y here and a y here, then that y times that y will get me that y squared. And it will also put a y to the first in the middle. So all we have to do is the same thing we did with the x's. I put the x in the beginning to take care of the x that was x squared and the x to the first in the beginning. And now if I add a y to the end of each binomial, then I'll get the y squared at the end and the y to the first in the middle. So we just gotta throw that extra variable in there, okay? Hopefully that makes sense. And that's a tricky one. You're not gonna see a lot of those, so don't freak out if that's still a little bit complicated. All right, now what can make this process really horrible is a really huge number, like this one. So 12, 8, 15, nothing in common. It'd be nice if there was a GCF That would make this a lot simpler, but there isn't. And when we multiply 12 and negative 15, I don't even know what that is, 12 times a negative 15, we get negative 180. So we're looking for factors of negative 180 that add to negative 8. Any ideas? Yeah, I don't know. Off the top of my head, it's not a number I'm as comfortable with as the other numbers that we've seen, and you're not going to see a lot of these either. But if you have this huge number that you have to find factors of, just don't stare at it because nothing's going to happen. Just start trying factors, and I literally will just start at 1 and then keep going down the list until I find the pair. So 1 goes in 180 times, and then 2 goes in 90 times. And remember, what I'm looking for is a difference of 8. So a difference of 8, okay? Does 3 go in? Sure, 3 goes in 60 times. That's not a difference of 8. Is 4 going to go in? Yep, 4 is going to go in, and you can use your calculator for this. Let's see, 180 divided by 4 is 45. That doesn't give me a difference of 8. 5 is definitely going to go in. 5 is going to go in 36 times. I still don't have a difference of 8. 6 is going to go in 30 times. 7's not going to go in. Is 8 going to go in? No, I don't think so. 9 will go in 20 times. We're getting closer. That's a difference of 11. 10's going to go in. 10's going to go in 18 times, and boom, there it is. And if you saw that sooner, awesome. If not, all I'm saying is when the number is bigger, just start making a list of your factors until you find the right pair. All right, so the right pair in this case is going to be not all this guesswork, okay? It was the 10 and the 8. Those are going to give me the difference of 8 that's in the middle. The 10 and the 18, sorry. So I'm going to make the 18 negative. That way when you add 10 and negative 18, you get the negative 8 that's in the middle. Now both of these have to be divided by 12. So divide by 12, divide by 12. This time both fractions reduce. And then if you don't like reducing fractions, I should have put this out there sooner. Your calculator, your Desmos will do this for you. So like 10 twelfths. If you put 10 divided by 12, it'll give you the decimal, but you tap on the little fraction in the blue over here, and it will convert it to a reduced fraction. So if you don't like reducing, use Desmos. It tells you this reduces to 5 over 6. And then if you have negative 18 over 12, again, hit the little fraction in the blue, and it tells you that reduces to negative 3 over 2. So both of those reduce, and if you don't like reducing, let your calculator do it. So 6x plus 5 is a factor, and 2x minus 3 is my other factor. Okay, so that took a little more work, just trying to find the factors. Maybe they jumped out to you sooner. If not, you know, in any case, just make the list until you find the pair that you need. Okay? All right, this last one is one that I will see people get tripped on often because it looks like it's going to work out so nicely here. So 1 times 11 is 11, and we need factors that are going to give us a 10. So the only factors of 11 are 1 and 11, so you might be thinking, oh, if I make the 1 negative, then they add to 10. But there's a problem with that. This is a positive 11. So the only way to get a positive 11 is if both are negative or both are positive. And this makes a negative 12, and this makes a positive 12. There's no way I can get a positive 10, which is what I need in the middle. The only factors of 11, right, are negative 1, negative 11, or positive 1, positive 11. In either case, they add to 12 or negative 12. They do not make the 10 that's in the middle. So what does that mean about this polynomial? Well, it means it's not factorable. So when something isn't factorable, that means there are no factors other than 1 and itself that go in. Okay, remember the long division of polynomials that we did? Right, we saw that some of the polynomials divided evenly didn't have a remainder, but some of them don't. Okay, they don't have any other factors other than a 1 in themselves. So just like numbers, right? Like 8, for example, we say has factors of 2 and 4 and 1 in itself. But if we have factors other than 1 in itself, that's called a composite number. Okay, what do we call the number when the only factors, like 3, the only factors, or 11, are 1 in itself? Well, it's called a prime number, and that's what we're going to call this polynomial. So when the polynomial doesn't factor, When it is not factorable, then we're going to call it a prime polynomial. If it's not factorable, it's prime. Okay, so we would not be able to factor that polynomial. Now, sometimes it's obvious. Let me just show you another one. Sometimes it's obvious, like, let's say we had like an x squared plus 10x instead of 11, like a 3 here. Right, the only factors of 3 are 3 and 1, or 1 and 3, or negative. It doesn't matter. There's no way we can get a 10 that's in the middle. So that one is very clearly prime. But you have to be a little more careful here because it looks like we can get a 10 out of the 11. Just be really careful with your signs. All right. So also I want to say, when you get to a problem like number 7, just because you can't find the factors, like if you didn't make it all the way down the list and figure out these factors, don't jump to the answer of prime because you can't find the factors, all right? You have to make sure you have exhausted all of your options before you say that the polynomial is prime. Hopefully that makes sense. Okay, so you've got some practice problems to work on. Try them out. And again, if you like another process you've already learned for factoring trinomials, by all means use it. But I think that in the long term you're going to like this one because it's pretty fast. But it does take practice, especially if it's new to you. So try it out, and then if you're struggling, just reach out. I'm here to help. All right, guys, take care.